This is one of my favorite kinds of infrastructure failures because it makes everybody blame the wrong thing. We had a Kubernetes based image build that would not complete. The build was running through the cluster. The registry was there. The Kubernetes objects looked reasonable. And naturally, the first reaction is that Kubernetes broke something. It didn't. The problem was two dead registries hiding inside the build configuration. The environment had multiple registries configured as sources for the cluster profile. Some of them were healthy, two of them were not. The build still referenced packs and images that depended on those dead registry entries. So the workflow would get part of the way through, then fail when it needed content that only existed through a registry endpoint that was no longer working. What made it annoying is that looking at the local Zot registry logs did not immediately show the failure. I tailed the deployment logs. I filtered for the workflow name, image manifests, signing activity, and HTTP 400 or 500 errors, and there was basically nothing useful. That is an important troubleshooting moment. No log output does not mean nothing is broken. It means the component you are watching might not be the component failing. So I backed up a layer. Instead of asking, why is Zot failing? I asked, what does this build depend on before it gets to Zot? That led back to the configured registries. There were 4 registry sources in the UI, 2 were dead, and then we got the clue that really gave it away. Trying to delete one of the dead registry definitions told us it was still in use. That meant something in the cluster profile still depended on content coming from that registry. Now we had a dependency problem, not a Kubernetes problem. I rebuilt the cluster profile using only the healthy registries. Same cluster, same Kubernetes, same local registry, same general build process, and the build worked. This is a useful pattern far beyond this one product. Modern Kubernetes workflows are dependency graphs. Your YAML might be correct while an external image registry is dead. Your pod spec might be correct while the image tag moved. Your controller might be healthy while a package repository disappeared. Your build system might be fine while one dependency URL is returning garbage. And because the failure eventually surfaces inside Kubernetes, Kubernetes gets blamed. When I troubleshoot this kind of problem, I work outward from the thing that failed. Can the node resolve the registry host name? Can it establish TLS? Can it reach the registry API? Can it pull the exact image or artifact manually? Is the credential valid? Does the build reference more than one registry? And does the profile contain old dependencies that are not obvious from the final workload? For an OCI registry, a simple request to the version 2 endpoint can tell you whether the service is alive. Then I try the exact image path. If authentication is involved, I test that separately instead of assuming the application is sending the credential I think it is. DNS deserves special suspicion too. A registry error caused by DNS still looks like a registry error to the workload. And in Kubernetes, DNS failures have a habit of multiplying because so many components assume name resolution just works. The important thing is to stop staring at the final error message as if it identifies the root cause. The final error tells you where the failure became visible. That is not always where it started. In this case, the cluster was doing exactly what we asked it to do. Unfortunately, what we asked it to do included reaching registries that were dead. Once those dependencies were removed, everything started working again. So the takeaway is pretty simple. When Kubernetes says it cannot build, pull, deploy, or start something, don't immediately start changing Kubernetes. Map the dependency chain, check every registry, check DNS, check TLS, check credentials, check the exact artifact, and check whether some old profile or pack is still pointing at something everybody forgot existed. Sometimes the best Kubernetes fix is leaving Kubernetes completely alone.